going live on YouTube. I don't know what the
All right.
for everybody. We're everywhere. Yeah.
All right. All right. Let's do this. Okay. Welcome back, everybody, to This One Time. This is episode. Jory, what episode are we on now? For let's call
18.
it season one. Sorry, what was that?
18.
18. All right, episode 18. Holy smokes. Okay. Yeah. So if you're listening this first time at this own time, we're sort of chronicling the journey here at Urban Machine about our development, designing a giant robot to recycle waste lumber from construction and demolition, put it back to work, and really the goal is to share our journey so that other people doing hardware development might learn something, and it's really all just about helping people move down the field a little bit faster. I'm not sure, Jerry, can you hear us still? Is it just your video that dropped out?
Yeah, I can see you. I think that's what happened. I think we're good. I can see you. I can hear
Okay, so you're
you.
still
I think my
cool.
end
Okay.
is in Chicago today. I know that's not saying much since it's the Windy City and all, but I think I lost my I think I'm good. I'm trying to catch up on oh, just see if it because on my computer it's not showing up, but I think you you have to
Cool.
love
Yeah.
technology, man. All right. Well,
Nice.
welcome to
Nice.
this one
Okay.
time, episode 18, the firmware frontier, right?
That's right. That's right. Yeah. Yeah. And like as always, driver's seat, Joy Wisniewski, leading the marketing operations here at Urban Machine. And today we're going to be talking about the firmware development frontier with Alvaro Martin. Yeah. Alvaro's been with us since May. Yeah. May. It's a few months in. Yeah, and yeah, we're gonna talk a little bit about this latest project that you've crossed the finish line, got the goal delivered on. Maybe before we jump into that, Alvaro, you want to introduce yourself and talk a little bit about your journey and how you ended up here?
Yeah, it's Alvaro Martin. I'm a shop technician here. Uh, I started, I guess, with tech in my last company, Plenty. I worked with Aiden there. I actually started in operations, and then I worked myself when I was going to school, and then I got a degree, and then I worked myself into a technician role in the shop there. So I help with things there, help with commissioning the farm over there in Los Angeles, and then after that, things happen. People let people go, and then I found you guys, and then actually I saw you guys from a newsletter, and I was like, "Ooh, that sounds cool." And then I think maybe you hired somebody or something happened, and then I saw the listing go away, and then it came back, and I was like, "Oh, I gotta go,
Yeah,
gotta go check them out." Came here, we talked. You and Eric, you guys have the
Great.
trailers, and then so yeah, I've enjoyed it
I
here
love that.
so far.
Yeah,
Everything happens.
yeah,
Andrew and I have talked about this a lot. That everything happens for a reason, and I think timing is truly everything. Right time, right place. I did not know that you and Aiden worked together.
Yeah, we were in LA working side by side, basically in the same area almost. Uh, but yeah.
Great.
yeah. And you didn't. So when you did, you know Aiden worked here
Um,
as
yeah,
came in?
I think I did.
Yeah,
Yeah, I think I did. Pretty
yeah.
sure I did because I was talking to my manager at the time, Tyler, and I think we had talked about that. Oh yeah, I think I saw on Urban Machine there was some posting or something.
Yeah,
Yeah.
which is great because obviously Aiden say like, oh yeah, Alvaro, we got to bring Alvaro on, he's awesome, and then Aiden could tell Alvaro that hey, this is not a horrible place to work. Over here.
Yeah.
Yeah, 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 and you've been like instrumental in getting like these last couple systems off the ground, keeping things running, getting our machines built. Yeah, just like sharpening the designs. Yeah, yeah, it's just like instrumental having your horsepower in the shop, getting things going. And then this last project too. So we'll start to get into the episode the discussion for the episode today. So this is almost, we're going to kind of take a detour into software land for just a second. Often the challenging thing about developing software for a specific hardware system is the timing and the access to everything, especially for, firmware is sort of a flavor of software that runs on the hardware itself. So it's like really close to the sensors and the actuators and all like the physical devices operating on the system. And that can be tricky because before that stuff exists, like before we've had a chance to build the robot, the software firmware team is kind of often stuck twiddling their thumbs a little bit. They don't have anything to actually write code for, and certainly not anything to test their code on, right? And especially when you have sensors and actuators in the loop, it's really hard to understand what bugs might be in your code, right? So there's this kind of disconnect where they have to sort of operate in a vacuum. Oftentimes, once the robot is actually built, then there's access problems because, on the hardware team, we're still fiddling around with it, kind of fixing hardware problems. And then we almost immediately ship the hardware device into operations. So suddenly for the firmware or software team to do any further improvements on it, they're doing all these crazy field trips, or they're interrupting operations, or they're like going in on evenings to do things outside of operating hours. So it's kind of this straining situation. So what we identified was we need some sort of like independent test stand that has all the, like, it's like a mirror of the actual robot. It has all the same sensors and actuators and all the other like IO devices we care about, but it's in a small little package, almost something you could fit on your desktop, so that the firmware team can run their code on this device, and it more or less can simulate the actual interaction with the hardware. You don't have the full robot, but it's like enough of a bare bones system that you can learn if your code is actually stable enough to run. So that was the need that we identified, right? And it was like, well, if we had some sort of a little like backpack type thing, then Tyler, who's running, writing a lot of firmware, all the firmware for us, like he could be decoupled from the actual robot development and operations process. So that was kind of like the start of it. And the kickoff was like, okay, let's like pile up a bunch of sensors and actuators and kind of dump them on a table. And then like Alvaro took on and was like, okay, I want to like I'll take on the challenge of designing this thing. Let's put a little package together for Tyler. And that was kind of that was basically it. That was like kind of the start of the journey. Yeah.
So yeah, you threw a bunch of things at me. I was like, all right, how am I gonna do this? I think at first we talked about like just doing this on I think plywood here is a big like back panel to use stuff.
Yeah.
So I kind of wanted to incorporate that, but probably use extrusion like a lot of engineers do, I guess. And I wanted to package it like really small, enough for him to like carry around easily, like go home, take it, maybe come back if he wants to work on it here. So yeah, extrusion, wood, some plastic, acrylic to cover it up a little. Along with all the electrical components and the motors. I guess before I come more from mechanical, so taking on this task was like nice to get more into electrical, and not just like plugging in stuff, but actually working with wires, cables, managing them, which is another whole layer of things, But yeah, I think it came out pretty cool.
Yeah, because the whole thing, not only does it have to house all the sensors and actuators, it's also a full analog of the whole control panel that has all the controllers and the power supplies and all like the power interruption management around that as well. So that also has to be part of the package.
I guess, can we reveal it now?
Yeah, let's reveal it. So
size-wise, what could you compare it to? Like,
it's like a toolbox.
Like a toolbox.
It's like,
okay.
Yeah, so here it is.
18
Actually,
here we go.
At the handle.
There it is, right here.
You brought it in real life.
Yeah, yeah. So there it is. Yeah, it's not light.
I was just gonna ask, can Tyler, carry it on
A
his
little.
motorcycle?
Some labels in there, but
It's like a boom box. It's like a healthy boom box, pretty much.
Yeah.
Yeah.
As
Yeah,
the
and then
marketing, I appreciate all the branding. Thank you.
Oh yeah. Yep.
Yeah.
I
So it has,
gotcha.
yeah, like it has lovely branding on here. Yeah. So maybe we can talk. There's a few I think particularly interesting features that Tyler requested.
Okay.
One of the specific things that Tyler wanted the ability to debug on this system was homing of various actuators. So a homing sequence involves backing out some axis until it bumps off of a sensor that basically says like you're in some set home position. And we have a little bit of a control sequence around that on the actual robot where like the actuator will like move some axis, some gantry, some system will back up, and then some sensor is going to trigger and say, oh, you're there. And then we repeat that process a couple times to make it more accurate. And
Okay.
we wanted to preserve Tyler to be able to run that code on this system. But of course, we don't want to package up all the actuator components in the gantries, right? We wanted something that was still going to be compact enough to carry around, but would still allow you to run this homing sequence. So do you want to talk about what your approach was there?
So yeah, I guess the approach was like just 3D printing something for like the motors. And if you see here, I don't know, like the sensors that we use are here. Um, so we just kind of came up with something that would set it off. So we put like a screw inside this 3D printed part here that's connected to the motor, so it'll spin and trigger that. Um, the axis you have up here, it's not just pretty, but like you have a reset button, you have an e-stop just in case the switch, and access to the clear core, to where he can interact and like see when lights are flashing and do things there. So I wanted that to be in the front and also the motor just because it'll look pretty too. You could have done this, I mean, infinite amount of ways, right? Um, and then the back with just like all the electrical stuff that is just behind the scenes that you don't necessarily need to interact, but you have access with the acrylic panels. You just release these little screws. Um, and yeah, so access and then like size and then yeah, portability maybe. Those are I mean, we didn't really have like CAD or anything. I guess this is just straight off my dome.
Yeah,
Basically, yeah. And then just working through things. I guess if I were to do it a little different, I would make it slightly bigger because doing some of the electrical back there was getting a little bit tough. But overall, I think it came out good, and useful.
Straining your
Yeah,
eyes
It's
and
not
your
pretty, but it works pretty nice. What was that?
I said straining your eyes and your
Yeah, yeah, yeah.
well.
Yeah. And then let's see when we. Oh, sorry, go ahead, Dre.
I was just gonna say you knew what you wanted it, not necessarily to look like, but you knew what it needed to do. How'd you come up with the mini me components? Like you said, you have the 3D printed. Um,
For that part specifically, well, we just um, so yeah, like in the machine, the way the sensors are triggered is from like surfaces versus the motor spinning to like trigger it. The motor is spinning, and then eventually a bunch of mechanisms move to trigger a sensor. But in this case, it's just a motor spinning, and you have a sensor. And so the simplest way I thought is, or if you're going to spin this, I guess Tyler does need to do some other things in order to make it work, because you're spinning a lot of revolutions versus here it's just like
Yeah.
one revolution.
Yeah.
But actually, yeah, this wasn't initially the design wasn't like this. I don't remember what we had designed, I think, to like make the sensors work, but ended up working nicely where the motor and sensor are installed on like the same bracket, and then you just have this spinny thing to trigger it.
Yeah, so
Yeah.
it's elegant because it's simple because it's like basically two parts, two 3D printed parts.
Yeah, two parts.
And you just attach the sensors to that, and that's all you need. Like it's like the most simplified
Yeah.
way to do this, which is always great. You always want to minimize the number of pieces in the system. Yeah. Yeah.
Just like the name of it, the spinny thing. I like it.
Yeah, exactly.
Elegant,
Yeah.
as a non-engineer brain.
And then, do you want to talk about like firing this thing up for the first time?
Oh yeah, it basically worked.
Yeah, right?
I think
Yeah.
we just didn't have the relays in the correct position, or they
Yeah.
weren't triggered, or the breaker.
I think yeah, we had the breaker flip. Like,
Yeah.
it was like, oh, at first we were like, okay, we're trying to get it going. We're like, oh no, is something wrong? It was like, oh no, we just had the fuse
Yeah.
flipped.
Yeah. A very nice mistake.
Yeah, and then we flipped that, and everything worked perfectly.
Yeah.
Like first shot. Yeah, which is, anytime you're doing this amount of wiring,
Yeah.
it's always huge.
You
Yeah.
did label it, but still gets. You could kind of. It almost looks like a rat's nest, but it's because it's compressed and like. But it's labeled. It's kind of like managed. Okay, so I think for like one of my first electromechanical projects, not too bad.
It's pretty sweet. It's
Yeah.
pretty sweet. Yeah, and then of course there's, you always got to think of the customer. Should we grab Tyler and
Oh, yeah.
and have
Yeah, I
him?
was just gonna
So
ask,
we're gonna do a
yeah.
cameo experience.
I mean, can he fit it on his motorcycle? That is a question.
Yeah. So Alvaro's gonna grab Tyler.
Okay, and that had to be kind of a proud moment for you, Andrew.
Yeah. All right, here he is. Welcome,
Hey.
welcome back. You want to sneak in a little bit?
I'll just.
Cool.
So,
All right.
present.
He did. Man, I got to see this thing from its humble beginnings all the way to now. It was quite a journey. It's really amazing. And it worked on the first try.
Yeah.
Which that is not common around here anywhere. So yeah, it's been super useful. I think it's going to be even more useful when we start developing new hardware again, or at least developing it to the point where I need to write software for it. And especially as we start deploying robots more and more, having something just at my desk that I can test it's invaluable. It saves me a ton of time and frees up the robot for other people to work on. So I'm happy. I'm a happy customer.
That's awesome. Well, a job well done then.
I also wanted it to go on your bike so you could just ride off into the sunset with the device in your back.
I love that.
I think I
Yeah,
like
I think if I tried to bike with it, I think I'd start doing wheelies. But honestly, I don't really work from home much these days anyway, so I'm not bothered by it at all.
it's a little heavy, but figure it out and get it home somehow if you need it at home.
Yeah, because there's a lot of good stuff in there. So what are you gonna do?
Right. I love it.
Of course,
I'm
they're
so
both back.
excited for you guys.
Those 4 servos pack a punch. Yeah.
All right. Awesome. Anything else you guys want to share about this delightful
Device.
device? It's like a mini because you've already built a mini robot.
That's
Now
great.
it's
Yeah.
The mini, the
Yeah,
baby
I
bird
think-
needed a mini.
Well, yeah. I think it's like when you're one of the lessons we have here is like when you're developing complex systems, anytime that you can kind of like break it down and run parallel development paths and just like unlock other parts of the team, even if you have to take a little detour and create a whole new system, like there's like a doubling, there's like compounding wins there from doing that, right? And just like being able to chunk things into their distinct components and develop them separately before integrating everything together. That's the big lesson for us, is that taking that systems approach is so helpful. Because now Tyler's really unlocked to do all this work in parallel while we fuss with the hardware.
Yep, absolutely.
Yeah.
I can't remember what the proverb is, but with Abraham Lincoln, do you? I don't remember exactly what it is. Yes, it takes more time, or do you just start going after it? And yes, taking a step backward to plan does take time at the onset, but in the long run, it does save you. And I think that's a really valuable lesson. Cool. Well,
Yep.
we have some we have openings at our machine, right? You want to talk about
That's
that?
right. We are hiring. That's right. Yeah, we are hiring. We have open positions. So if you're interested in working on this sort of stuff, and also you're interested in sustainability, helping establish circular economy, look us up, urbanmachine.build. We have a careers page there. We'd love to hear from you. And also, always interested in hearing from other folks in the hardware development community. If you see something here that you want to engage and start a conversation around, or throw out ideas of how you've approached projects before, that's what this is all about.
Yeah.
Engineering in the open.
Yep,
Right?
absolutely.
How we do it.
Yeah.
Building the community. I love it. It's such a different way of thinking, and that's kind of our brand anyway, right? Changing the way things.
That's right.
Well, thank you guys. Thanks for joining me today. I look forward to in 2 weeks we'll be back, and I will be in California, and we'll have hopefully a live demo of the real robot out at Zenker.
Yeah, on site at the pilot. We're gonna do a little field trip. Yeah, it'll be an
That's
exciting
exciting.
episode. Getting out of the office. Yeah, it should be
Right.
fun.
Woohoo.
Yeah. Super. Cool. Thank you, Joy.